Okay, so here I have a particle that is at rest, and when I click this button, this particle will move to the right, picking up speed as it does so. So let's look at it. There it goes, picking up speed, and we see the displacements increasing as it moves across. A very interesting question that we need to answer now is, why does it pick up speed? We are going to say that this particle picks up speed because there is some influence that's making it do so. This particle is being influenced in some way to increase its speed in this direction. This influence we are going to call a force. So our initial definition of force then is going to be that it is an influence that can affect the speed of a particle. We're going to run this animation again, but this time we have drawn a vector to indicate the influence, the force that is acting on this particle and making it accelerate. So there we see the force acting on the particle, making it speed up. Because this force is constant, the rate at which the velocity of this particle increases will be constant. In other words, for a constant force given some particle, the acceleration will be constant. So this is very important, and we'll state all of this over again in a more formal way. But note that if I were to increase this force, then the rate at which it picks up speed would also increase. In other words, increasing the force that acts on a particle increases the acceleration. In this case, we'll have a particle that is moving to the right but slowing down as it does so. So let's see how that looks. So obviously, if this particle is slowing down, there must be some influence, some force acting on it. However, in this case, in what direction do you suspect that influence must act? Well, since it's moving to the right and slowing down, that influence should be exerting its effect to the left. In other words, the force that acts on this particle should be pointed to the left. So let's see that. So here it goes. Note, it's moving to the right, slowing down, and so this force must act to the left. This means the acceleration is also to the left. The net force, and notice I've introduced a new word there, net, and we'll discuss the significance of this in more detail a little bit later. The net force acting on a particle, in this case, since we are only dealing with one force, I can simply say the force that is acting on this particle has to act to the left if, as it moves to the right, it slows down. What's going to happen after a while, however? Can you guess what's going to happen as this thing slows down and comes to a halt, the force remaining constant? Well, if the force continues to point to the left, it should slow down to a halt and then start picking up speed back to the right. So let's take a look at that. So it's slowing down at a constant rate, constant acceleration because the force is constant, and now picking up speed back. Notice? So this vector here represents force. Notice we could also use a vector very similar to this one to represent the acceleration, because the acceleration will always point in the direction of the net force, and since in this case we have only one force, the acceleration must point in the same direction as this force. Now we're going to have a particle move to the right at a constant speed. So there we go. Since the speed and the direction of this particle remain constant, there is no influence acting on this particle to affect its motion. Either that, or if there are many influences, these influences cancel out, and as a result, the net influence then must be zero. So to make things simple for right now, we'll simply talk about the absence or presence of a single force. So in this case, there is no force acting on this particle. This is very important. For motion to occur, it is not necessary for a force to act on this particle. It's only if you want to change the motion in some way that you must have a force. So if a particle is traveling in a straight line with a constant speed, there is either no force acting on it, or if there are many forces, they cancel out, in which case then the net force would be zero. The preceding discussion is equally valid for vertical motion. So in this case, we have a particle that moves upward with a constant speed. Therefore, the net force acting on this particle is 0. There is no net influence acting on this particle. For this particle's motion to change in any way, there must be some net influence. So for example, if we want the particle to move up and pick up speed as it does so, there must be some influence acting upward. In this case, we have the force acting upward, so this particle, if it leaves from rest, will pick up speed as it moves upward. So there you see it, picking up speed as it goes upward. The acceleration is constant. It picks up speed at a constant rate because the force is constant. Now the particle, in this case, the particle will start out moving upward, but since the force is downward, it will slow down as it goes upward. So there we have it, slowing down. Of course, if we continue to allow this particle to move upward, it will eventually come to a halt and start coming back downward. Notice the force is constant all the time, therefore the acceleration is always constant and acting downward. So I hope this little presentation allows you to see the connection between force and motion, especially the acceleration of some motion.